All right, just like we did before, let's break this down step by step. So right there in question one, we are specifically talking about the wire to load 3. Okay, the wire to load 3 is going through that pull box, and it is in that conduit with 9 wires inside of it. Now the wire itself is a 6 gauge, so let's just write that on our chart, and then we're going to write our other modification factors in there. We do have 9 current carrying conductors, so I'll just write CCC, 9 right there. And then for my temperature, I'm 121 degrees Fahrenheit, so let's just write it right down there at the bottom. Now, when we do these, again, we're going to go through this a couple times tonight, kind of in our outro, but we are looking at a number 6. Now, in our curriculum, and most of the time, it's pretty okay to just guess that this is going to be a THHN number 6. Now, typically in ours, that is the roll, and if you're taking the test, I believe they have that same mentality that you're talking a THHN in copper. Okay, so THHN, again, is going to be a 90 degrees Celsius rated wire. If you have any concerns with that, cross-reference 310.4 just to make sure that you're on the right page. Okay, 310.4 is going to have those properties for all of these. It's a little bit more useful than just looking at this section at the top here. Okay, it's going to give you more detail, but these give you a rough breakdown. Okay, so that number 6 being a THHN and a 90 degrees Celsius rated conductor is worth 75 amperes. So let's start our calculation right there at 75 amperes, and then we need to go through our adjustment factors. Okay, the first one on the list is going to be those current carrying conductors at 310.15 C1. Okay, and in this case specifically, we have 9, so we will be in that 7 through 9 category for a deration factor of 70% or 0.7. Okay, so let's pencil that in. Next and most nextly, we have our temperature adjustment. So we are going to go up or back to the left in your book, and then I got those two tables. I went ahead and cleared it so I could just do this one more time. Just ignore that table at the bottom. When and if it comes up, which it doesn't very often, we'll talk about it at that juncture in time. But most of the time we are going to be using the top temperature, which is based on an ambient of 86 degrees Fahrenheit. That kind of national average for a temperate zone. Okay, and this question specifically asking about 121 degrees Fahrenheit. Remember, you have Fahrenheit on the right and Celsius on the left. Make sure you're in the right category. 121 happens to fall right in here, 114 to 122, and then we need to select an adjustment factor that will be based on the temperature rating of the conductor. Now, since we've already associated that as a 90 degrees Celsius rated conductor, being THHN, we will take that adjustment factor of 0.82 right there and add it to our calculation. 0.82. And then let's just multiply it out. Okay, no need to separate these in any further capacity. Okay, we're just going to take that 75 right out of 310.16. We're going to multiply it by that 0.7 out of 310.15 C1. And then we're going to multiply that by that final 0.82 that we got within our last temperature adjustment table there. And we're going to come out with 43.05 amperes. Okay, 43.05 amperes. And then we will just select that Charlie right there out of the test. Okay, so that is your mainstream, your most common one you're going to see, probably the one that will happen more often than not, where you're getting a number of current carrying conductors, a specified wire, and a temperature adjustment. Okay, that's your most common scenario with these, and it kind of touches on all the bases. So hopefully that last run through helps a little bit there. You got it. Just practice a little bit more, and you're good.